Saw someone couldn't open the agenda. I'm not sure what the issue. I just checked
Yeah.
it didn't open, but
At times it may, because there's a link on the restricted site, it might have to do with a Google permissions.
yeah. So you do have to be logged in with the email that has restricted access. Okay, so really this has a familiar flow to the webinar. So we'll situate the course. So I'll take a peek up. There's the idea capture tool. I'm going to close that because I have it open on another tab. I guess I didn't. Good. I'll just show where to show that because we'll come back. Home, timeline for the patterns course. So just right there up at the top is the timeline. So that gives you sort of the overview of the whole year as a visual overview, but we are now in unit 4. And so really starting to pick up the performance expectations, right? That is a little slow, but these performance expectations are really meant for at the end of high school grade band. So we found that it did take some time to thoughtfully build student skills up, but you can see now that we have 3 performance expectations. Here is a list of opportunities to assess students and give them feedback. But just know that this is a unit that there are things when people are behind, we strongly suggest cutting. So we'll say that in the flow of it. So you might not give all of these. All right. That's the year-long overview. And I think I'm going to hand it to Matt to do the teacher calendar, and then we'll hop back to me to talk about begin with the end in mind.
Yeah. Thanks, Bedford. So again, this unit is situated by around how, what's that?
Yeah, I knew something was weird. So actually, I think we said that we are going to show the quiz first, and then you were going to do the teacher calendar.
Okay. Yeah. Go ahead.
I knew something was funny when I said it. Might even actually, I'm going to show the answer key, I think. So this unit, so there's multiple structures going on in the patterns physics curriculum over the year. So, obviously student talk and the role of scientist and engineer are throughout, but some units need to take a heavy lift. Some units need to take a heavy lift on the evaluate published materials. Some units need to take a lift on building graph literacy. I'm thinking unit 1. This unit, we needed one unit to do an extra dose to really give students enough time on task for informational text. So what I'm showing you here is the final quiz. And we've gotten mixed reactions. Sometimes people are like, whoa, no way my students can do this. And so we want to show you this, and then we want to tell you the unit about how it is an intentional 4 to 5 week learning progression to get students ready for this. Okay, in any case, what is it? This is around engineering a shoe. And so one of the final assessments, they have a engineering portfolio, but the final quiz is around making a data-informed shoe design. And there is someone that you see in the first quiz, a person, an electrician, and we actually return to her at the end on the final quiz as well. Okay, so here is the goal of this quiz. I'm going to give an overview and then I'll go back and look. So they just got a design specification table. So it talks about a bunch of different shoes, and it has the cushioning force and stability needs of these different types of clients: runners, dancers, smoke jumpers, EMT, and then the electrician is added for the quiz scenario. So they get a new person. So there's a design specification, then there's a manufacturing specification that, again, so the point is there's 1 table, 2 tables, and a graph. And I'm showing you the answer key. So this color coding is the skills that we're teaching students to be successful with this. And then there's also reading. So this is that heavy lift on getting students to get more comfortable and feel okay going from text to 2 tables to a graph, and they all interact. So, hopefully it's showing some rigor, or you're seeing the rigor. And then the final piece is a claim evidence reasoning around their data informed design. So that's just a peek at that last one. Maybe I'll jump back to the blank copy so it doesn't look, that color coding can sometimes be overwhelming. I'll say it one last time and then I'll hand it over to Matt. So they have one table about shoes and what the clients need. They have a table on the manufacturing around cushioning and mass and stability and the trade-offs there. And then they also have a graph of some impact data about what it's like when someone, when that foot strike hits the ground. And then they got some interview notes about Adalia. And after that, they just got a very simple structure here, and they can decide actually which of these to use, but they got to write out their data informed design. Okay, with that, I'll hand it over to Matt to give an overview of what it takes to get students ready for this.
Yeah, so again, we'd like to start with the end in mind, but also want to give you just an overview of things to come that, of course, we're going to go into a little bit more depth. So in this unit, we are looking at, how do design and STEM work together and to bring imagination into reality. So we start, like many units, exploring our engineering challenge. So at the start, students are playing with their shoes, they're testing friction and testing the stability and cushioning, all of these different factors that affect, and really thinking about what makes it a great pair of shoes great. And it really does depend on different situations. So we are, exploring our engineering challenge. After that, we need to get some more in-depth data. And so we actually run two labs in parallel because of at times schools don't have the equipment. Impulse experiment, where you're looking at the cushioning on a shoe and seeing how different amounts of cushioning affect that. Also, some students could be looking at friction as well. So really modeling through an analogous system of study, how do we model the impact of a step, and then what does that look like in the graph? We have the tangent out on momentum, which we'll talk about. We'll look at Newton's second law, and then ultimately at the end, students are designing their shoe and really thinking through the trade-offs of different situations of stability versus weight, and looking at different things that might trade off when they are ultimately coming up with their final design. So the big arc there is looking at design and giving students some opportunities to think through what makes their best shoe great in there. So I'll hand it to Bradford to talk about the hook that is at the start of the unit.
Okay, excellent. Matt already talked about one of the best hooks that we have is really just talking about what makes your favorite pair of shoes your favorite pair of shoes. So that's actually the first question we ask them in this unit. The other piece of the puzzle that is really nice and gets a pretty good reaction. This is from the New York Times fashion section. So it does happen to be about Nike, so it's definitely also a commercial.
At times, the scale is overwhelming.
Sorry about that. It functions as a commercial, of course, for Nike as well. But I want to pause. With students, we pause multiple times and see how many things we've already done in class in patterns physics that they mention here. So they're going to talk about data, analogous systems of study. It's very hard to study a basketball player on the basketball court so that you recreate that experience. Data informed design decisions. Okay, with that, I think I should stop and reshare my screen optimized for video. And hopefully that works. If you have a lot of trouble, or I know sometimes it can be glitchy, you can see this, it's right embedded in 4S1. And thank you to Ajay and David, who did the work of getting all of the safe links. Yep, so you can have ad-free safe link, and that link is good forever. So in any case, I'm playing this one. I think I didn't have an ad, so I got away with it. All right, here we go. I'm not gonna pause. I'll be very tempted to, but just there's a lot of really good stuff right out of the course, and of course, it's nice that it's coming from a professional setting.
Overwhelming. I mean, we participate in every major city, every continent, everywhere I can go. I know that sports has an impact. One of the things we hear all the time is how great it is to run on grass. So we just said, well, what if you actually married fake grass on the bottom of your shoe? And it's not a real shoe, but it's this sort of wonder experiment about like, hey, where can we take cushioning? We're incredibly excited to have this enduring brand of the NBA, decades old, meet this innovation brand of Nike and come together. Our process in designing the jersey is kind of a case study of the way that I think we design. Typically, we will start lots of our design work with intel from the NSRL, Nike Sports Research Lab.
We try and understand the movements of the athletes, the forces that are on their body, and how the footwear or the product that we put on them affects their motion. One of the things that's most important when you're looking at different sports or different athletes is to make sure that we can recreate the environment that they're going to play the game in.
You can change temperature and humidity in this environment from very hot to very cold and very dry to very humid.
We try and understand what are those drivers that make you say I'm uncomfortable. It might not be how much you're sweating, it might be how the apparel is reacting or clinging. So we attack a problem that way. People might say, why do you put so much science into it? Athletes in general, we say they're getting bigger, stronger, faster. This is one of those things where you can objectively look at that.
Data-informed design lets us begin in a better place. We start with knowing exactly what those bodies are needing to do, where their friction points are, where their distractions are, and how we can design to literally erase or take away any of those distractions.
So this is BRS Studio. This gives us the ability to very quickly bring ideas to reality. From the research, the analytics, it leads us to more of the art part of the equation where we've got to make some decisions based on that data. So if we look at what the maps tell us, we know where the garment has the potential to cling against the skin. We know where the body is heating up during the activity. So we simplify that heat map and that cling map into two zones. And what you see in the area of the red is where we need the material to not stick to the body. And what you see in the lower area is where we need the garment to really ventilate. This jersey over here is a really good look at what it looks like before the teams go in and start working through the team identity. The texture has now been engineered into the backside, which is what's going to keep it away from the skin. My personal collection, I've got Vapor Max, I've got the original AJ1s. My current favorite shoe of choice is the Air Max 97.
How many pairs are in my closet? That's not a really nice question, I guess. I probably have, at the moment, I would say 120 to 160 pairs, I'd guess. Well, with the Hyperdunk, it's kind of like the shoe that everyone can wear and perform to the highest levels. With the new knit direction, we're really tuning around the foot what we need, where we need it. We actually have a design team that's specialist in knit, and they'll design all these knit structures around the parameters that we're looking for. Here at the end, this is a TPU yarn, so you can see there's zero stretch. And it goes all the way to the top where these yarns, you can see here, the structure really stretches. I have here the LeBron 15. You can see exactly then how we've taken the original kind of swatches and then applied them through the design. Obviously, an athlete like LeBron, he's landing very heavily and he's powering off really fast. So really, heel lock is really important. So we're using this kind of lockdown effect around the heel to really stabilize him and lock him in.
When I look at product, I'm looking at, is it better than it was before? Have we improved the ultimate performance for the athlete? And then, is there a cultural, iconic narrative that's baked into the uniform that breeds emotion? First time we get to, with the NBA, really compose the entire uniform. That's remarkable.
It makes a familiar kit like the Lakers
Feel fresh.
completely new.
Yeah, I agree. It's awesome.
The smiles that we got from the players when they put that jersey on, they knew, this is the best thing ever. That's when I think we know we're done.
We believe that they're going to show us whole new chapters of athleticism in the game, take the game someplace new. Can't wait to see it on court.
Okay. Yeah, just to make it a little more interactive, did anything resonate with people? Did people see some key things that we've championed in the class show up? Might be just nice to hear connection points that people saw. And just as if people give you a little bit of time to think about that and type that up, one other big piece that we'll say a couple times during this webinar is shoes oftentimes grab different students than some of the prior stuff in class. So we very intentionally pick shoes, although I do want to just right away say some teachers also find that switching out the shoe for a helmet is a great fit for their classroom as well. So that one as well. The shoe does have that art component, and there's just a lot of students who do like shoes and all of a sudden feel a connection. So that was a very intentional piece of this, but there is always, of course, flexibility. I see a hand raised.
Yeah, shoes are a high interest item, and I like that the testing is done. I've seen in Matt's classes that testing the different components helps develop a good decision for the final product towards the end.
Awesome, thank you. Yeah, hinting at, in fact, that's actually what is coming next, is that right away on day one. So we watch that, we go with students about, yes, the iterative design, data informed, that analogous system of study. Lots of times I just get so excited, I actually show clips of that video, even during the tomato lab for quadratic in unit 1, just showing that, oh man, it's really hard to study a basketball player while they're playing basketball. You need to recreate that system in a controlled way. So we're always doing similar things like that. And I think I will. Oh, I just got lucky. Look, we are going to do that exact experiment. I'll keep it small screen, I'll keep it small screen.
And understand the movements of the athletes.
Okay, so good. We have that sensor that is on the supply list. So that's going to be the first experiment. They are going to do that one. That one actually happens to be very much nicer than the ones that we have. But I want to point that out because years ago, we haven't had this as much, but years ago when we first released this unit, teacher said that students really struggled with connecting the experiment to the project. So just one, and we haven't heard that, so I think we've gotten a lot better. But look at that, they're basically that's doing a foot strike, and then a little bit later they even show some of the data from it. But okay, so with that, I got myself off track, so I'm gonna hand it over to Matt to wrap this piece up and take us to the next step.
Sorry, I'm muted. Yeah, so we really do want to start with that eye in mind for design, and we need to also look and see, what's the design problem? What are we trying to do? So we explore a new design design cycle. We've thought about the engineering design process for several units. And this is just another iteration of that. Bedford, if you could flip over to the 4EP there. we give them their engineering portfolio for the shoe. And on this, they have, we call it a business proposition. You've probably seen this before in other units with their proposal. And the storyline here is that they're trying to break into be a breakthrough shoe company. But there's a really big market and popular market in like basketball shoes and cross trainers. So the idea is that there's other markets that don't have very many that are still easily to break into. And so actually, I think it's probably better to scroll down. And so they choose those and they have some client profiles. This is one that we want students reading and close reading and kind of doing some inferences. So there are a smoke jumper, minimalist runner, EMT, and dancers. These are all different clients that they can profile and or that they're profiling and making their design about. And we chose those intentionally. Those all have different trade-offs that they make. The smoke jumper needs cushioning, but like the lighter the better and the more support. And so there's a trade-off there. And so each of those within that reading, there is some hints and some clues and some things that students need to make inferences about and start to think about what their design priorities are. If you scroll down, thanks, Bradford, there's we start to get to this idea of like, what makes a good shoe. And so thinking about what's the biggest priority. And so we assign, a point value, like maybe 14 points, and a 4 means the most important, and a 1 means like could be left behind. And so thinking about each of those different cushioning, stability, mass, traction, and style, thinking about how students have them make a justification. Does a runner need a minimalist runner need cushioning, stability, mass, traction, style? And so they assign those points based off of thoughts and based off of like class conversation. Of course, we have them make a problem statement right at the beginning of who they are, who their client is, and then they refine and peek at their design. So this first day, again, is always about getting that big idea in mind and getting the task of the project. And after, students are going to start to experiment with those cushioning, stability, mass, traction, and style. And so I'll hand that over to Bradford to talk about.
Excellent. We will actually do one of these in the workshop, but I'll just say it does throw people and it totally makes sense, but we are utilizing a engineering tool, but lots of times teachers and students, including myself, you kind of intuitively think the most important thing ought to get a 1, but anyways, it makes sense to we want students to think about that. So that has thrown a lot of teachers. So I'm not sure I'm explaining it well. You want to think of it as a magnitude of priority. So the more important something is, the more weight you want to give it. And so 4 is the most important thing. Even the number 1 priority would get a score of 4. A little bit confusing, but the slides help with that. Just wanted to call that out in the webinar, that you'll need to take a little bit of time and think about why that works. Because if you only have 10 points, well, then if you give something 9 points because it's super important, well, now you don't have any points to give to anything else. So it sets up that trade-off. Again, students sometimes get confused by that, but it takes a little bit of time and then everyone figures it out. Okay, so Matt had just mentioned that. So another piece of Unit 4 is it is so hands-on. They're tinkering. It is being playful. So I would just want to jump to that. Again, it could even be day 1, but I do actually think everything is a little more puffed up after the pandemic. So maybe it's day 2, but the idea is you go and they explore data. And this is meant to be done with their own shoes. However, some students don't like, they're worried about if their shoes smell or anything like that, or some students love taking off their shoes and testing their shoes. Other students think that's the most embarrassing thing ever. So if you can plan ahead, it's nice to have just some other shoes in the classroom. So just a little, but in any case, they just go and do cushioning. They actually do that little experiment where that we saw in that thing where they hit their shoe against the force sensor and look at, we're in the webinar. So I do want to tell you, this is where we teach students to use the force plate. That takes 10 minutes for a student to learn to use the force plate. So we want to get that done before the lab starts. So it's really important to do this tinkering, plus it's kind of fun. And then stability. We have videos that go with each of these.
They're on the next slide.
Yeah, we'll just show the picture. We weren't going to play all of them. So, and I think the picture will actually help with this. I'm going to come back to stability. Mass is so easy, right? They just literally get out a spring scale or put their shoe on a scale. Traction, very popular physics lab, right? Where they start to just look at how much friction it takes to do it. So I will jump over. Here is the slide deck that, oh, I did want, oh yeah, there's so much to share. But the exploratory data collection. So cushioning, each one of these has a tutorial. I'm not going to play it. I'll just show it.
When you're launching a new product with a tight deadline.
That is why we want the safe share link. So annoying that we have to go through that, but okay. Stability, mass, traction. I thought, again, there is a little video tutorial that says how to set each of these up. Stability, that's really easy with a water bottle in your shoe, because an empty shoe, the center of mass is way too low on an empty shoe because of the weight of the sole and the traction. So in any case, and we go over this, is that a good way to test the shoe, to have no foot in it? No, we got to simulate a foot. So in any case, if you show them this slide, they can just read it. But if you talk about it beforehand, again, that's what we mean, playful tinkering. And if they say something else like, I don't know, I can't think of anything, but, and you have those materials, we go with it. So, but a water bottle is something usually that we have in class. You probably had some after unit 3 with the bungee jump, using the water bottles there. So you have them around. It's really kind of the next day after the bungee jump. So the water bottles are there, you can put them in, and then you just start to tip it over before, until it just falls. Okay, mass I already mentioned, and traction we said. So that's that quick overview. There's like, these are not experiments. They're really tinkering. We want students to get a feel. What angle does a shoe start to tip over? And cushioning, it does not matter what data they get. We are just, the goal here is that they learn how to use the force plate. They are going to do a full 2-day experiment coming up. This is the pre-lab to teach them how to use cushioning. And then mass is just so simple, and I'm repeating myself. So with that, I'm going to do the quiz, and then I'll throw it back to Matt. So here's that quiz that we talked about. It connects what I was just saying. Here's those priority points. So they get a limit of 16. And again, look at this informational text. They got to read and then deal with a table. And they have 16 points to divide up among these. And of course, if you give more to one, you have less points to spend or prioritize other things. And everything has to have at least 1 point. And again, just to get this more creative and opening it up, based on the reading, they are supposed to add one more parameter. And there's a couple options that they can pick from in that reading. And then we realized that we didn't assess really on their understanding of the engineering design cycle. So a real light touch, couple multiple choice questions. Again, this is informational text. We were thinking like ACT. This is sort of the style and the unit that could get a student ready for ACT style questions. So again, had the couple multiple choice. And then again, see the baby step. I hope I'm calling out the baby step. Remember I showed you the 4Q5, the final quiz. This one is a lot simpler. There's just one table. there's informational text and one table, and they got to do the one table and come up with an answer for what's the best place to start with designing a shoe based on the table above. Okay, so again, they're a very intentional arc to get students ready for that high level informational text at the end of the unit. Okay, with that, I'll hand it back to Matt to talk about that first key experiment.
Yeah, thanks, Bradford. So, Bradford, if you could go over to the slides, I think I'd actually maybe want to show slide 45. So, thanks. We are looking at, again, analogous systems. So how can we model the impact of a shoe? We need to know more about cushioning so we know what our clients need. And so in this lab, students are modeling the impact of a shoe by using a mass. We've gone to using water bottles rather than like metal masses, foam, and a force sensor. So the foam represents the cushioning, and the force sensor is picking up the force that it's hitting with. And for us, a water bottle is looking at the is representing the shoe. Water bottles are also nice because they don't ding up the force sensor or the floor as much, and just are a little bit bigger and closer to the size and weight of the shoe there. And so this one is a lab that we assess on a quiz later. We have given it as a lab write-up, but in this unit there's 2 labs where students are taking data, and so due to time, we opted for this one to have them take data, analyze it, process and understand what is going on with the impact and how that impact can be mitigated, but assess it on a quiz rather than on the lab. So again, our research question there is, how does the time of impact affect the average force of impact? And Bradford, if you could flip over to the key over. Actually, yeah, so there is a video on the slides of how to take data for this one as well. And those are going to be iterated and improved on as well. But students are changing their water bottle and seeing that time of impact and what's happening. This is also one that at times we will have students share their data and get like a crowdsource of data. But as you scroll down, they change the number of layers of foam. And one thing that they're processing is they're changing the layers of foam, and that will ultimately change the time of impact. And as they add more and more foam, they can actually get a visceral feeling or hear of that impact gets, that force, impact force gets less and less. You hear it less and less. It gets cushioned more and more. And so one piece of foam or even 0 will have that really high force in a low impact time, but as they add that more foam, the impact force will decrease as they go down. And so students are living that experience and seeing that, but also to add an additional element of rigor, there's lots of different variables for them to ultimately figure out what is going on with the number in the equation, the C value, that constant. So we've got force of impact is some number, that 3.6 divided by the impact. And I think I'll leave it to Bradford to talk about the data discussion and how do students get that idea of what does that value mean.
Yeah, excellent. Thank you. Yep. So I want to start with, this is actually very intuitive. Once you say impulse or even impact force and time of impact, but students get it. When you add more cushioning, it goes from whack that Matt just mentioned to vroom. So I do want to, this is a tough lab. So I just want to own that and acknowledge it. But I do want to have people realize that students do have a pretty intuitive grasp on what cushioning does. And that is actually what's pushed us to use that phrasing, cushioning. Of course, we do want to get them to the technical language, impulse and force and time. But in any case, to hit some of the highlights of the data discussion, this is a case, and this is one that you really have to slow down and go over students, and it's really great. This unit is about graph literacy and informational text. So most students will not get this in 2 minutes, but we are not saying take 2 minutes. Take 10 minutes with this, and students will start to notice, like, and there is an accompanying slide that allows you to project, and I could flip to that quickly. I don't know if that's good to we got this one. I'm looking at this one that's in the upper right here, and that is oops. Okay. This is what, okay. So students need guidance with this is what I wanted to say. So I see people looking at their screen a little bit. Thank you. And okay, so yep, if we look at this one, that orange one, which is the one, look at these, what are things you notice? Okay, but we'll focus on this. This has the biggest number. It has the orange furthest away. And then lots of times it's the most extremes that are easiest to compare. This is the smallest number. What's different? Oh, this is the high mass. The water bottle is almost full, and it's a high height. And oh, this is low mass and low height. And look, it has a small number. So again, the overall trend that it's inversely proportional is one that I'm kind of jumping over the place, so I apologize. Many students do actually hypothesize this. They're not like super confident that they got it all figured out, but they know that with more cushioning, the force is going to go down. And so again, because we have the confined playground, they know it's not proportional. With more cushioning, it's not more force. And it's certainly not with doubling the cushioning makes the force 4 times bigger. That doesn't make sense. It also doesn't make sense that more cushioning doesn't do anything, horizontal line. And I point that out because when students go in thinking that it's inversely proportional, because we've slowed down and given them that chance to hypothesize about that, they are in a much better space to make sense of the data. So if you rush it and skip the hypothesis, students land at inversely proportional and they're kind of like, what? Okay, so I'm not helping that, I'm jumping around. So again here, oh, so this, what is different? And I'll just, again, I want to show how much, if you had a shoe, I wish I had a shoe, but okay, if we drop a high mass from a high height, wham, if you drop a low mass from a low height, oh, so I just want to say, like, they know it's like oomph, or oh, that's like, oh, impact. And I just want to say, we want them saying those things, right? Swirl, speak right, interact, read, and listen. So they're doing all of that to get them started on this data discussion. I just say that because it's really important. If you just give students 10 minutes or 15 minutes to work through this data discussion, we've gotten feedback that it doesn't go well. So really take some time, work with students to orient to the data. And then they go through with the similarities and differences. And this is, the 5th or 6th or 7th lab. So they're getting pretty good, hopefully, with the similarities, differences, and predictions here. And then, of course, walk the triangle. What does that mean in terms of each part of the triangle? And I will go back to that slide. So lots of times we always start with the mathematical model. Oh, what is that? Where's the constant? Oh, it's the number. And oh, stomp. That is a big one. If you go around stomping your foot and dropping those water bottles, every student gets the bigger the number was the bigger stomp. And then, of course, on the graph, if you have a bigger stomp, that's going to move you further away from the origin. If you keep the time the same with a bigger stomp, the force is going to be bigger. Yep. And then at the end, just to show, like, there's no, of course, we have one technical way, which is really nice to have just one technical way, but there's a lot of different ways to say it. Stompiness. A lot of students say something like force time. It's the combo of force time. These last two have come up many times. So because the water bottle, the way that we're controlling the stomp is by controlling the height of the water bottle, a lot of students fixate on that. And so they know it has something to do with gravity. But of course, that is how the water bottle gets moving so that it then hits and comes to a stop. And so, something like mass velocity stoppage, it's just creative. I'm not actually saying use these. Sometimes some teachers don't like these words at all, but stompiness is a good one. I hope you do find that one useful. And then it is that combo of force time. So that is that baby step. And of course, the technical name is impulse. That never really rolls off most students' tongue, but we do want them to feel good about it and realize, oh, there's an update. Just try to clean it up a little bit. But yep, force of impact is going to be the impulse divided by the time, or the stompiness, or the mass times the change in velocity. All right, so that is a key lab here that does a big lift, and no surprise that when the time of impact gets twice as big, the impact force gets twice as small. Excellent. With that, I'll hand it over to Matt to just give some other closing comments about this experiment. And take us
so just a few things, and I'm not sure if I followed the chat completely, that the C value, the constant in this experiment, really does mean the impulse, or sometimes my students, one that maybe we should add to that is like the impact. Somebody who is, and we do get lots of practice with that in other situations. So we'll look at it for like a helmet, and we add there's like a small storyline, a small aside on a warm-up where students are looking at new helmets and how airbag helmet, things like that. Looking at the impulse or the impact and seeing like that big idea of, we need to increase, if you want a low force, you need to increase that time. And so, sometimes we'll talk about, how you catch an egg or things like that, you give with it to increase that time and lower that force as they are looking at that. So there are several other practice, and I don't know, I don't think it's going to be worth it for our time, or I don't think we have time to look, but in the packet, there are several practice problems and looking at new situations, looking at situations where landing with flat feet versus like giving with landing flat-footed or landing athletically where you're bouncing your legs. You can actually jump on those force plates. Those force plates are strong enough to handle a student jumping on it. And so looking at those situations on how does that increase in the time decrease the amount of force over that period. So there's lots of different fun situations that we look at. We elicit student ideas, looking around the world, like students come up with little things like a door that you are closing that slows it down, or cabinets that slow down, or adding any of those little bumpers to allow something to increase the time and lower the force there. Good, yeah. Maybe just for a second, Bradford, if you want to head back to the agenda to check in, and then.
Great. I think I closed the agenda here, but I will. I do think that's a good one. We're covering a lot. Or actually, I need the agenda right here. Slide that over. Okay, so to see where we are, we were just discussing the anchoring experience, and then looked at the data discussion. Yep. And that, so good. Got a couple more things, and then we're going to do a breakout room to give you a chance to do a little bit of connect and processing. But just to finish out the second lab that Matt mentioned. And so I will say in the storyline, sorry, this is a little confusing, but I do want to say it. I'm going to open part 4. We are skipping this momentum here in the middle because it's not strongly connected to the storyline. It is a departure from it. It does intellectually fit right there, but some teachers prefer to put it at the end. And we always get this question, if you're behind and you're not going to get to Unit 6, electric guitars and climate change, this is something to cut. It's a good day. We got it down to 1 day. It's a good day. It's all videos. It's fun videos to watch. But, you know, sometimes you're just in a position where you can't do it all. I would say this is a obvious thing. If you have to cut something, this is an obvious thing to cut. So we just talked about the impulse lab, and now we're going to jump to Newton's second law here. Skipping this, this was a reach goal for the webinar. So you can tell there's a lot in this unit. So we will come back and show some of those videos. It's fun, but it's not mission critical to the storyline. Okay, with that said, I need to jump back to the agenda and then orient myself here. We need to determine the mathematical model for forces and acceleration. Close that. And we're going to take a peek at the key. This is another lab, a little bit like elastic energy, if you're close to that one or have looked at that one, where doing the lab is the learning. And I mean, start to finish, not just making sense of the graph at the end. So there's a lot going on here. This is actually, again, system analysis. We teach them free body diagrams in order to do the lab. So we're looking at the key, and I'm now thinking that it might be nice to see the regular one. So I'll quick model that. I'm going to go to our unit, and I'm going to go to the task. That is, there's the momentum. Here is that. Here is the blank lab template. So I'll just preview that. And so here is a system analysis, and all the arrows are pre-made so that it's a Google drawing. So you click, and oh, that's interesting. That's super interesting. That's an unexpected result. I don't know why that is like that. It shouldn't be, and it doesn't match the picture here. So in any case, you can tell. So this is just as Matt said, we have students jumping on the scales, the 4 scales, and they have to make sense of the forces. So I'm going to jump back to the key now. And this is just a webinar, so we're trying to give an overview. I'm not going to try to say each little move, but they make some mistakes with the arrows that, like, lots of times when the jumper is in the air, they want an arrow going upwards. And of course, they're moving upwards because they have kinetic energy that is transforming to potential. They have momentum, but what they do not have when they're in the air is an upward force on them. And so this is the learning for that. So that is going to be something that students do. And then you walk around and formally assess, and some students will have it, some won't. And that's a great time to say, hey, why don't you check in with your table mates over here, or check in with this group. They have a different answer, and figure out what's right. And students eventually all get it. And especially with teacher guidance, then they definitely get it. But lots of times, student to students, they can figure it out. But just want to point that out, because it'll start with like 80% of your students will have an upward arrow on the jumper when they're in the air. And that's a good nugget. They do have something upward, right? It is momentum or kinetic energy, but this is a force diagram, a free body diagram. And there is a warm-up activity. This is not the first time they are looking at the force arrows. Then such a useful tool that so many times there's so many arrows, it can be overwhelming. We, of course, want to draw just the total force or net force. So again, similarly, but on a different diagram so that we don't get confused that the total force or net force is just another force. It is actually all of the forces added up. Then again, they have to place these 4 arrows. And again, it's still, even though you had that discussion the first time, they just feel that a downward arrow while the jumper's in the air, that's not intuitive to a lot of students. That takes some exposure and practice before they master it. Okay, with all that said, though, I just want to point out that the lab scaffolds the learning, and that is with teacher guidance. And that guidance doesn't have to be the teacher telling them. That can be the teacher connecting lab groups that have figured it out to lab groups that haven't. Okay, with all of that, though, they get the net force. This lab is so tricky. This one, we actually have them data mine. So they take existing data sets. We do suggest demoing this, having students jump and record it. It's just so messy. You don't get a clean data set. It's really crazy. However, it might be years or 2 away, but if you have the ability to start making some purchases, Vernier and I'm sure Pasco probably also has this. They now have a cart that will export force and acceleration data. So it'll be a couple of years before we can really integrate that. But if sometimes teachers and students don't like data mining, that's such a good thing. That's a big part of academic research, and a big part of industrial research is that you take data sets that already exist and ask your question. Just to finish that out, there is potential for a real live action one, but that does require very expensive equipment to get good data. And there is, of course, Atwood's machines and other things. We have not had good experiences with 14-year-olds with the Atwood machine and understanding that you're keeping the mass constant and changing the force. That has not gone very well. So this one has gone well. I do want to say that, but if you want that live action and you have the ability to get carts that directly output the force and acceleration, that's a great one. Maybe as if force plates, we've done a combo of force plates and accelerometers. It's really messy, but if those accelerometers get better because they're being put in phones and all these other things, that also might allow for a live action one in the coming future. All right, but to show what the materials are that are here, they're just given data, too much data. And again, this unit is about graph literacy and dealing with tables and too much information and learning to pull out just the information you need and strategies. So because we're looking at the key, it's already color coded for the answer. But this is what students need to do. So again, just want to show this lab is a learning experience way beyond just the conclusion they reach from analyzing the graph. This is teaching them graph literacy. And of course, I should ground this in the question. How does unbalanced forces affect acceleration with mass held constant? Okay, well, they're given a data set up top. Oh boy, a data set up top and a data set below. And you just got to look at all of these things. Okay, here's the mass of jumper, force of gravity. Wow, there's so much. I'm so confused. Okay, what do we do when we're confused? Slow down and maybe just take one example. So just want to show that we are trying to teach students how to handle this and how to deal with that overwhelmed feeling. I am monitoring my time, so I'm going to try to wrap this up and just say, for the question that is, how does an unbalanced force, well, to have an unbalanced force, I would want different ones. So yep, in the end, I'm going to take this column, ignore all these other columns, and the acceleration column. So they only need these 2 columns to answer that research question A, but they had to learn that and they had to analyze 8 columns to figure out which were relevant. And of course, just that check with mass held constant. And then of course, if you compare, this data set has a changing mass and a constant force. So that allows them to answer that second question. How does the mass affect acceleration with force held constant? So this lab is loaded with good stuff. So even if you do get that cart, you will lose some things by not doing the data mining element of this. Good. With that, I'll throw it over to Matt to just make any last summarizing comments for this experiment and take us forward.
Yeah, so we are getting close to a breakout room. We just wanted to look over some opportunities to practice and apply. So this is in the packet, and so maybe we'll look at those opportunities both for impulse and Newton's second laws, and then we'll head into a breakout room to reflect and look at that. So if you could click on 4P there, Bradford. When looking at Newton's second law, first is if you scroll down, we are looking at mass and acceleration, net force and acceleration, and we want to apply this back to that same idea, that foot strike. And so really cool website and data of looking at, and you can see the graphs, and it won't be worth it for us to go into the site, but you can see this group, I think it's out of Harvard, took data on the force in terms of body weight of a foot while they're striking the ground. And so you can see the graph there, the video, that bit.ly up at the top there has the foot strike data on it, and you can see in live action when somebody's running how that force is changing. So we're pulling those ideas of mass and force back to acceleration in there. And then Bradford, if you don't mind scrolling down just a little bit, the data goes further and starts to look up a little bit there. Looks at a heel strike and a toe strike, so different ways of running, and looks at and has students using ideas of impulse, force, mass, and time to figure out which impact is greater. So connecting those ideas of that collision with acceleration there. And so trying to pull those ideas from momentum back to these live images of heel striking and toe striking, things that are sensors that our force sensors or vernier force sensors can do, just not nearly as elegantly like on a treadmill as these ones. So they are able to get those applications and move those. And then that table is just that table at the bottom is just another kind of practice at using net force and using acceleration as they are doing there, and looking at different runners and how their masses are being affected. So lots of practice and getting students looking at different ideas. There's a chance for their students to make an argument, like a counter argument against somebody, and gives them opportunities to think about those. With that, we are at a really good spot here to really take a little bit of time to go into a breakout room and check in. I need to quick set up the breakout rooms here. Bradford, if you could put the prompt in the chat.
And just to read it so you hear it a couple times. Reflect on, choose one of the following. Career connected learning. We didn't hammer that or mention it too strongly, but that quiz has lots of details about electrical career options. So something that students really ask about, has a salary that a lot of students are like, what? And then focusing on shoes as a hook. And then that idea of the tinkering with the mini experiments, where students are just handling something and taking data on almost a daily basis in this unit.
Good. Give me just 1 second. Sorry, I'm getting this set up. It's lagging on me. All right, almost got it. Okay, we've got some breakout rooms set up there, groups of 4 or 5, just giving you some time to reflect. I'm going to make the breakout room here for 5 minutes, and we will come back together and look at the end of the unit here. So let's see. Here we go. Opening those up now. I'm going to pause the recording.